Hello and welcome to an installment of Chang Academy, where today I will be showing you Bayes' theorem. That's right. So let's start off with the story. Daniel and I were playing Pokemon, right? And so I feel like I want to play Pokemon now. So I download an emulator, and then that sparks a question in my mind, and it makes me ask, do people who have Nintendo devices play Pokemon games? So I did this survey, and out of 50 people, this is what our results got. So, owned a Nintendo device, not owned, and then right, make our graph here, and then these are people who have played, so we'll put a yes for played for Pokemon, and no for people who haven't played Pokemon. Now, for the people who own a Nintendo device and have played Pokemon, we got an outstanding result of 39 out of 55. For people who do not have a Nintendo device but have played Pokemon, we simply got one person. For people who own a device but haven't played Pokemon, we got 7 people. For people who did not own a device nor did never play Pokemon, got 8. And now I'll go ahead and write out the totals. So out of a total of 55, 40 here, 1, 9, 46. Alright. So now let's go ahead and make our chart. So we'll go ahead and write out people. So our first row is people who owned a Nintendo device or not. So out of that we have 84% and then 16%. Now, of the people who do own a Pokemon device, we want to determine whether or not they have played Pokemon. And for that, people who have played Pokemon is 85%. And then people who haven't played Pokemon but do own a Nintendo device is 15%. And now over here, people who have not played Pokemon but have played, people who is 1%. People who do not have a Nintendo device but have never played Pokemon before give us a result of 15%. So wow, quite the chart here. So our overalls end up being, so this essentially means 39 out of 50, so that's going to be 70%. This basically means 7 out of 55, so we get a 13%. The 1% means it'll be 1 out of 55, so that's going to be 2%. And then 15% over here simply means 8 out of 55, so that ends up becoming 15%. Correction, this should be 88%. Okay, so now that we have our chart, I'll now explain to you Bayes' theorem. Now essentially, now we're going to find the probability of A of B. Now A of B is essentially asking for probability of A over a total probability of B. Now for us, that equals Um, so the probability A is going to be 7.7% here. So we'll go ahead and write 0.7. That's going to be over probability of B, which is going to be 0.7 plus 0.15%, right? Because these are the people who do play Pokemon games. So then this is 0.7 plus 0.13. That equates to 82%. Now we want to check for the negatives, the people who didn't say no, who said no. So we have the contrapositive of A and everything but B. So this equates to 0.02, right? Because this is the people who said no to Nintendo devices and said yes to playing Pokemons, and then we put that over 0.02 plus 0.13, because this group is are people who haven't played Pokemon. So 0.13, and that equates to 13%. So right off the bat, we can definitely see that Bayes' theorem definitely shows whether or not tests are working. Judging by the 82%, we can definitely conclude that this test is positive, whereas our hypothesis is correct, where if someone owned a Nintendo device, then they played Pokemon. Now, possible outliers could be downloading an emulator or whatnot and playing Pokemon through that. But yeah, besides that, thank you so much for watching and have a nice day.